Okay, let's dive into this explainer and put on our mathematical detective hats. If you're gearing up for your Grade 8 geometry assessment, you are in the exact right place for constructions, proof, and semester assessment. Today, we aren't just going to memorize formulas. No way. We're going to learn how to truly investigate geometric claims, separate fact from fiction, and apply precise mathematical reasoning to solve some pretty complex problems. By the end of our time together, you'll be armed with the strategies you need to confidently tackle your mixed review challenges and prove your answers beyond a shadow of a doubt. So, let's get started.
Section 1. The Geometry Illusion.
We're kicking off our investigation with a classic geometric crime scene, a scenario where a simple visual guess completely leads us astray. So imagine an 8 by 8 square. We know from basic geometry that 8 times 8 means this square has a total area of 64 square units, right? Okay, now imagine we cut this square into 4 distinct geometric shapes, specifically 2 identical right triangles and 2 identical quadrilaterals. But here's the crazy trick. When we rearrange those exact same 4 pieces to form a long rectangle, the new shape suddenly appears to be 5 units high and 13 units long. And, well, 5 times 13 gives us an area of 65 square units. Wait a minute. We didn't add any paper. We didn't stretch the shapes. So how on earth did we magically gain an extra square unit of area just by moving the pieces around?
This brilliantly illustrates a huge danger in geometry: trusting your eyes. When you look at that newly formed 5 by 13 rectangle, your brain totally tells you that those 4 shapes fit together perfectly. The edges look flush, and that large diagonal line across the rectangle looks completely straight. This is what we call a visual guess. But as mathematical detectives, we know that area is completely additive. If you take shapes apart and put them back together without overlapping, the area has to stay exactly the same. The visual guess tells us the shapes fit perfectly, but the mathematical evidence tells us that 64 absolutely does not equal 65. So, one of these has to be lying to us, right?
Section 2. Constructions support mathematical claims.
To solve this mystery, we really have to understand how precise, formal constructions act as our undeniable evidence. Looking at the standards for mathematical practice, Practice 3 tells us that mathematically proficient students must construct viable arguments and critique the reasoning of others. That basically means we can't just say, well, it looks like a rectangle. We actually have to prove it. Furthermore, Practice 6 demands that we attend to precision to uncover the truth. We've got to be careful with our definitions, our units of measure, and our calculations. It's exactly this strict adherence to precision that's going to help us explain the mystery of that phantom 65th square unit.
Section 3. Modeling a short proof.
Let's see how this builds into modeling a short proof that busts this geometric illusion wide open. To do this correctly, we're going to leverage this incredibly useful 7-step problem-solving strategy for geometry applications to really structure our proof. Okay, so step 1 is to read and understand the shapes. Step 2 is to identify what we're actually looking for, which in this case is why the combined shapes don't make a true rectangle. Step 3 is name the variables. Step 4 is translate the situation into an equation or mathematical model. Step 5 is solve using solid algebra. Step 6 is check our work. And finally, Step 7 is state our final answer. By sticking to these steps, we make absolutely sure our argument is structurally sound and pretty much undeniable.
So the crucial turning point is right here. To figure out why that 5 by 13 rectangle is a total illusion, we translate our visual of the diagonal line into algebra. How? By calculating the slope of the top edges of the shapes that make it up. Let's look at the green quadrilateral piece first. To get from one point to the next on its top edge, we move down 2 units and to the right 5 units. That's a slope of -2/5 or -0.400. Now look at the yellow triangle piece right next to it. Its top edge moves down 3 units and to the right 8 units. That's a slope of -3/8 or exactly -0.375. These slopes are extremely close, which is exactly why your eyes fold, but they are absolutely not the same line. Because the slopes are different, the 2 segments combined do not make a perfectly straight line. There's actually a long, super thin, empty space running diagonally right through the middle of that supposed rectangle, and the area of that exact, nearly invisible gap is precisely 1 square unit. Boom! Mystery solved, all thanks to precise mathematical modeling.
Section 4. Semester Mixed Review Challenge.
Now that we've seen just how vital precise evidence is, it's time for a student-ready mixed review challenge to lock in your core semester concepts. I want you to pause this explainer right now. Grab some scratch paper and use the distance formula to find the exact length between these 2 coordinates on a Cartesian plane, -3, -1, and 2, 3. Remember, we are looking for precise mathematical evidence here, not a visual guess. Go ahead and pause the explainer now.
Okay, let's see how you did. If you followed the steps correctly, you started with the distance formula, which we know is derived from the Pythagorean theorem. You plugged in your coordinates. Taking the x values, 2 minus -3 gives you a positive 5. For the y values, 3 minus -1 gives you a positive 4. You squared them to get 25 and 16, added them together, and arrived at the precise mathematical evidence of the square root of 41. If you got that exact radical, fantastic job. You're attending to precision just like practice 6 demands.
All right, here is your second pause check challenge for our semester review. Think about the property of similar triangles we've studied this year. Pause the explainer right now to clearly state the geometric rule and explain how you would calculate a missing side length.
Welcome back. You should have realized that based on the property of similar triangles, two things are always true. Their corresponding angle measures are exactly equal, and their corresponding sides are always in the exact same ratio. Because of this awesome structural rule, if you need to find a missing side, you simply translate the relationship into an equation by setting up a proportion. From there, you solve the proportion using good algebra techniques like cross-multiplication. It's just another perfect example of how algebraic precision gives us concrete proof in geometry.
Section 5. Recap and transfer question.
Let's wrap up our investigation with a quick, concise review of our detective work. As you study for your assessment, the big takeaways you need to remember are pretty clear. First off, visual assumptions are super dangerous. Just because two slopes look identical to the naked eye definitely doesn't mean they actually are. Always demand mathematical evidence. Second, precise geometric constructions and definitions are what actually support and prove your claims. Third, use a structured, step-by-step strategy to model short, undeniable proofs. And finally, apply these exact same precise methods whether you're calculating coordinate distances, finding midpoints, or solving for missing sides in similar figures.
As you head into your big semester assessment, I want to leave you with this final thought to really challenge how you apply your new investigative geometry skills outside the classroom. Think about architects designing a massive skyscraper, or engineers plotting an international flight path. Where else in the real world might a visual guess lead to a disastrously different conclusion than strict mathematical evidence? Take that critical thinking with you into your exam and beyond. Thanks so much for joining me on this explainer, and hey, good luck on your assessment. You're going to crush it.